Today I'm gonna walk you through the algorithm, how to create this generative algorithm. So every time we click randomize, we would get a new artwork. So let's dive in. First thing to know is creating these artworks with Vsketch. This is a generative art toolkit for Penplotters, and it is written in Python. Let's start. I have here open complete fresh Visual Studio Code window. So if you type ls, which is list directory, you can see it's completely empty. So I'm gonna start from scratch. So let's go first through the installation. Copy this command without the $sign. We copy this, and then the next command. Then we create our virtual environment. And we activated the virtual environment, and then we type pip install. This might take a few minutes, so be patient. Okay, now the installation is done, and if we type ls, we can see right now we have already the project. Now we're gonna create the project from scratch. So the first thing we're gonna do is we're gonna create a directory with mkdir, and this is gonna call it my sketches. Change directory into the folder I just created, and here I'm gonna run the command to initialize the project, which is vsk init, and then the name of the project. Here I'm gonna call it random lines, and then he's gonna ask me which page size, so I'm gonna go with A3 because this is the size I plot. I'm gonna go to portrait, so I say landscape no, and then if we go here to our folder structure, we can see that in my sketches, now here there is a folder random line. Inside this folder there is a sketch random line.py. So if we open this, the vsk init command created for us this template, then we're gonna run it. So in order to run it, we just type vsk run, and then the name of the project, random line, and then we should see an empty sketch. Now we're on a blank sketch, and we have the code. In order to do this algorithm, the first thing we need to do is to create a grid of points. So I'm gonna go for row in range 20, then for col in range 25, vsk.point, row and col. Now if we look here at the screen, we right now see that the grid is created. The next step is to move each point a little random to in the x dimension, in the y dimension. So in order to do this, we're gonna create a variable called x. We're gonna set it to the row, and then a y is gonna be to the col, and then we're gonna add a random amount, vsk.random, and here you can pass a boundary. I'm gonna go from 0 to 1. Right now Vsketch is taking the measure in centimeters, so this is gonna be from 0 to 1 centimeter. You can also change the scale and change the parameters here. We're also gonna do it for the y coordinate, and then we're gonna do the point x and y. Now we see we have a little random points. The next thing we're gonna do is we're gonna group the points in such a way that for each column is gonna be grouped in a list. If we go change a little less random so you can see what I mean. Here we're gonna group this row in a list, and this in a list, and every column, I'm sorry, every column we're gonna group that in a list. In order to do that, we're gonna declare a variable that is gonna contain all the lists. So this is gonna be a list, this is gonna be a list, and we're gonna have another variable that is gonna contain all the lists. So we're gonna create it in all columns points, and then it's gonna be an empty list. And then for each column, we're gonna create column points. Then in each iteration, we're gonna append or x and y, so append, and then we are gonna append it as a tuple. And then at the end of each iteration, so after this for loop is done, we have one column So we append this column to the all column point. All column points dot append column point. After these two for loops, we're gonna have stored all the column points in this list. Now we're gonna get each column and the next column, and we're gonna interpolate this point with this point, this point with this point, and so on. In order to do this, we're gonna say for index range, and then the length of the all column points, and then -1, because we're gonna access to the next item. We're gonna say the current line or the current point is gonna be all column points and the index, and then we're gonna do the same but for the next column point. So these are the two columns that we're gonna interpolate soon. We need a list of each coordinate separately. Let me explain. This current column point is a list of tuples. If we print this, let's go with print current column point, you see there is a list of tuples, but in order to create the linear interpolation, we need a list of numbers, of floats. So we need to unzip this list, and in order to do this, we first get current column points unzip. We do this by saying the zip operator and then the asterisk and the current column points is a zipped object. We need to create this as a list, so we're gonna just cast it as a list. Now we have here a list with two elements, and the first element is a tuple with all the x coordinates, and the second element is a tuple with all y coordinates. Now we need to create a numpy array with the x coordinates and with the y coordinate. First we need to get the x tuples. X tuples is gonna be the first element of this list, and the y tuples is gonna be the second element. Now we need to convert this to a numpy array, so we're gonna be able to interpolate them later. So in order to get it to a numpy array, we can just say x coordinate current column, and this is gonna be an np. We need to import numpy because otherwise we're not gonna be able to use it. So numpy as np, and then here we say numpy.array, and then we pass the x tuples, and then we do the same for the y tuples. And now we have the x coordinates and the y coordinates in a numpy array. Now we need to do exactly the same thing, but for the next column points. I could write a function that do that for me, but as we're just gonna do it one more time, I'm just gonna duplicate the code so it's a little bit faster. So now we just change here this to the next, and next, and next, here also next. And we can reuse this variable as is a temporary variable, and then we just need to change this guy here, and we can change the name here for the next column, and here also for the next column. So if we see here, we have the x coordinates, the y coordinates, and the x coordinates for the next column, and the y coordinates of the next column. What does that mean is that we have right now in this array the x coordinates of these points, and in this array the y coordinates of this point, and this from the next point. Now we're gonna interpolate them. As we want to also interpolate them many times, we're gonna create a variable like interpolation steps, and then let's first start with 9, and then for interpolation step in range of interpolation steps, then we are gonna interpolate the x and the y of each one, and then we're gonna zip the values, and then we're gonna draw our polygon. So in order to do this, we go and say interpolated x is gonna be to vsk.lerp, which is linear interpolation, and then here you see we can pass a numpy array. So we're gonna pass the x coordinates for current column, the x coordinates for next column, and then we need to pass an amount, which is a value between 0 and 1 that tells us how near is the interpolation to the first value or the second value. So being, if you pass 0, it's gonna be exactly this point. If you pass 1, it's gonna be exactly this point. So we need to iterate 9 times. So the first time it should be very close, then next time a little longer. So we're gonna do it something like interpolation step divided by all the steps, because this is always gonna give us a value between 0 and 1, and then we can use this for the linear interpolation. Now we do the same for the y coordinate, and in the y coordinate we just type here, change the x to the y, x to the y, the index, the amount should be the same. Now we want to zip these two values, so we go into the interpolated coordinates, and then we can do like zip interpolated x and then interpolated y, and then we can use the function from Vsketch to draw the polygon. So vsketch.polygon, and here we just pass the interpolation coordinates. Once we save it, now we can see the lines, but right now it doesn't look so random, and that's because we changed this value for the explanation purpose, but now I can change it higher, and now we can see that we have here our algorithm. We can also comment this line so these points don't appear, and now we can, if we click on randomize, each time we're gonna get a new value. We can also play around with the amount of randomness, so if we put like 3, we get different results, or we can put here 1 and here 1.5. We can also change the amount of columns and the amount of rows. A very nice trick would be used to use the function linspace of NumPy. So instead of putting here 20, we can say something like np.linspace, and then we can pass here, I don't know, 0 and 20, but now we want only 10 columns. Now it's less, but we can amend this value to 20, or we can do this to 15. So you can play around as much as you like. That's basically it. I hope you enjoy watching, and if you have questions about Vsketch, you can also find here in the documentation. So here in the reference, you can see here, for example, let's go to the Vsketch class. So this is the most important class, because here you have all the functions: circle, ellipse. We're only using the polygon. We're using also the lerp, which is here. Interpolate between numbers, alright? We interpolate it over the arrays. But yes, you can be creative and play around with this function. So I hope you enjoy this, and if you want to support the channel or you want to support me, you can think about liking and subscribing, as well as also buying our artworks as NFTs or in our website.